This video is sponsored by JLCMC. More about them later in this video. Hi there, this is Ayush from Master Mechanical Design, and in this video, I'm going to give you a complete guide to designing the mounting arrangement of LM guideways to achieve highly accurate and smooth linear motion in any machine or actuator. We will explore all the recommended installation method of linear guideways, their design, benefits and tolerances you need to maintain. Then I will show you how to create GD&T based manufacturing drawings for mounting arrangement for both the guide rails and the LM blocks. Because of precise motion, the parallelism and flatness of the resting face are extremely critical, and these tolerance depends on type, size and preload class of LM guideways. I will show you how to find these data in manufacturer's catalog and then how to use it in your design and drawing. After that, we will go through the practical recommended steps of installing LM guideways, like how to identify the reference faces of guide rails and blocks, then how to tighten them properly, the recommended torque and the bolt tightening pattern. And throughout this video, I have shared several design pro tips, so make sure you watch this video till the end. So let's start with single guide rail and block mounting arrangement design, and then we will move to double guide rails mounting arrangement design. So when we are using a single guide rail, we can simply mount the guide rails and the block on flat surfaces like this. Just use the clearance holes and threaded holes provided in guide rails and the block. No special mounting features are needed. And since there is nothing to cause misalignment, you won't face any problem in getting a smooth motion. But in some applications, we need positional controls over the LM guideways, even in single rail setup. For example, let's say we have a go, no-go inspection gauge pin mounted over LM block, like so. And this pin is used to check the diameter and position of the hole in this product. Now, because this is an inspection gauge, the position of pin itself need to be very precise in both in height, in vertical plane, also in width, in horizontal plane. The height of this pin axis is controlled by the size tolerance of these mounting blocks and by the overall height tolerance of this LM guideway. The height tolerance of LM guideway depends on accuracy class of the selected LM guideway. We will talk about that in separate video. But to fully control the position, we also need to precisely locate the LM guideways from the sides. And since there are no double hole on either the rail or on the block, so we need to design the mounting arrangement something like this. We provide alignment steps for both the guide rails and the LM block. But the things not done here. After the manufacturing of all these parts, during assembly, we need to make sure the LM guides and blocks are installed in right orientation. The LM guide rail and the blocks comes with reference surfaces for alignment. On the guide rails, the reference surfaces are marked with small arrows like this. That face acts as datum surface. As shown here, it's datum B. So during assembly, this face must sit flush with alignment step. And on the LM block, the reference face is grinded surface. As shown here, same as on the top face. Only the grinded faces is actually reference. This one here, marked as datum D in this diagram. And this reference face should touch and align with the locating step. I hope this is clear so far. So let's quickly summarize. If you only need a smooth motion, you can directly mount the guide rail and block on flat surfaces. We will talk about flatness tolerance later in this video. But if your application requires positional control over LM Guideway, then you must design a proper alignment steps for both the rail and block. And during assembly, make sure the guide rails and LM blocks are mounted against their correct reference surfaces. Otherwise, you won't get that positional accuracy defined by the Guideway manufacturer. Now let's understand the recommended installation method for double LM guideways, which we use in most of linear actuator and sliding system. So first we will go through the different installation concepts, and then we will talk about the tolerance and GD&T of the mounting arrangement with an example. So first off, when we use two or more LM guideways in parallel, we shouldn't mount them directly on flat surfaces. In double guide rail arrangement, the flat surface mounting is just not recommended. Not recommended at all. Why? Because LM guideways are generally designed with negative clearance between the groove and the ball to improve stiffness and ensure high precision. This means there is no internal play between the rail and block. So LM guideway cannot absorb any misalignment. So when we slide a platform over two parallel rails, the parallelism between these rails must be precisely maintained. If not, even a small misalignment will lead to high friction and LM guideway will wear out much faster. So to maintain accurate parallelism between two guide rails, we need to design the mounting arrangement like this. We provide alignment steps for both guide rails. And for LM blocks, we align only one side blocks using an alignment step. The other side of blocks is kept free, mounted on just a flat surface. Otherwise, another problem will start, which we will discuss just in a minute. And to keep the guide rails and block in place and properly aligned, we permanently clamp them against the alignment step like this. Because LM guideways are not just designed for the motion, they are designed to take the loads in all the four directions: upward, downward, sidewise. In applications like CNC machines, guideways experience heavy load, vibration, and even impacts. So it's necessary to use clamping arrangement to hold both the rails and the blocks securely, and to keep them parallel and stable under real-world operating conditions. Now, before we understand different clamping methods of LM guideways, let me quickly introduce the sponsor of this video, JLCMC. JLCMC is a complete mechatronics component marketplace. They offer almost every mechanical and automation parts all in one place. From all linear motion components like linear buses, linear shaft, linear motion guideways, and ball screw, to the power transmission components like coupling, timing pulley, timing belt, racks, pinion, all types of bearings, and all essential machine design parts like springs, hardware kits, latches, locks, shock absorber, you can name it. And the best part, you get high quality components at lowest price possible with fast global shipping. Every product has their proper data sheets, and they have maintained industrial accuracy benchmarks. You can see their LM guideways comes with proper preload and accuracy classes. So you are not just buying a random parts. You can select and configure the exact spec you need. Download the CAD models, fit in your design, and then place the order. And pricing, you will find pre-built linear actuators started from $80 to $100. Honestly, no one offers this quality at that price. Not just actuator, almost all the parts are listed at very economical rates. And here is a real bonus. If you are a new user, you can get $70 worth of coupon plus monthly deals on registration. So don't forget to register. The link is right at the top of description, also in pinned comment. So the clamping of LM guideways can be done using one of three methods. The first method is clamping with a push plate. It looks something like this: a C-shaped plate, one face touches the guide rail and other touches the edge of the mounting plate. The same method can be used for the LM blocks as well. You can design and manufacture these plates based on the size of guide rail and block. Usually, the plate has 0.5 to 1 mm of undercut. Plate thickness you can consider 10 mm, and you can keep one or two mounting holes. Depending on the size, these plates are also available as a standard brought out item. And it's recommended to use these plates at every 20 mm along the length of rail. So when we tighten the bolts, the plates pushes the rail and the block tightly against the alignment step and fixed it in that position. Just one thing to note, the outer face of the LM guide rail and the blocks should exactly match the edges of the plate. If it doesn't align, the plate won't clamp it properly. Now let's say the LM guideways are not mounted at the edges of the base plate, but somewhere in middle. In that case, we can't use push plate, right? So second method is Taper Gib method. In this method, we machined a taper slot along the length of LM rail and block. One face of this slot should be perpendicular and under the rail and block of 2.5 or 1 mm. And the outer face of this slot should be at taper, ideally at 15 degree. And then design the taper gibs according to the depth and width of the slot. Also, you need to keep a clearance of about 0.5 to 1 mm around the gib plate to allow it to be tightened. For example, in this setup, I have used LM guideway size 20, and based on that, these are the dimensions I used. Now, when we tighten the bolts on the gibs, it slides along the tapered face and push the rail against the alignment step. And the same logic applies to the LM blocks. This method is much more rigid as compared to push plate method. Now, the third method is clamping with a push screw. This is typically used for only the LM blocks. An advantage is that it's very easy to access and tighten from the outside. But issue is that the screw can be loosened over the time and can leave a mark on LM block. So personally, I usually avoid this method. So let's talk about which method to be used, and it mainly depends on your design. If your LM guideways are mounted at the edges of the plate, you don't have much a choice. You will have to use push plate method. On other hand, if LM guideways are mounted somewhere in middle, you will have to go with the Taper Gib method. But if your design is flexible, means you can decide where to mount the LM guideways. Then if your design is related to CNC operation or there are vibration involved, go with Taper Gib method. It's more rigid and robust. And for general applications like SPM machines, the push plate method is more economical and work well. Now, if you are wondering, why don't we fix the both LM block with the alignment step? Why do we keep one LM block free without any alignment? So first off, to achieve the smooth motion in dual LM guideway system, we only need to maintain the precise parallelism between either the guide rails or between the LM blocks, not both. If we align the guide rails properly with alignment step, then LM block will automatically stay parallel because there is no clearance between guide and block. So both block can be mounted on flat surfaces and motion will be stay smooth. Similarly, if we fix the block and move the rail, then we can align the block only and skip the alignment step for the rails. Either way work. As long as one set is aligned, the system stays smooth. Then why do we still add an alignment step to one LM block? So the reason is not the smooth motion, but the positional accuracy of the sliding plate. Without any alignment step, the sliding plate position will float because the LM blocks are mounted only with the clearance hole and threaded holes. There are no dowel to lock their position. So we align and clamp one side block and that guideway becomes the master. It controls the position of entire system, and the other side is called the subsidiary guideways. It's left free to compensate any manufacturing and assembly tolerance variations. The big advantage of this approach is that we don't need to tightly control the distance between alignment steps for the both guide rails. Even if there is a significant relaxation, say plus minus 0.1 mm, the subsidiary block adjusts because it's not hard fixed. But if we fix both LM block, the system becomes over-constrained. Then the distance between guide rails alignment steps as well as LM block alignment steps both must be highly accurate, or else we will face tight motion and friction. So it's always better to keep one side master and one side free. And just a note for non-interchangeable guideways. Non-interchangeable guideways means the LM block and LM rail are supplied as a matched set and cannot interchange with other. But in most of designs, we use interchangeable guideways where rails and block are brought separately and can be interchanged. We will talk more about that in coming video. But in case if you buy two sets of non-interchangeable guideways, then you will get one as master and one as subsidiary guide. For example, in Hyvin, the master is marked as MA. In TSK, it will marked as KB. So during assembly, make sure you mount them accordingly. Now in some setups, the LM guideways are mounted sidewise. Even there, the same logic applies. Align the both guide rails with alignment steps. Fix one as a master. On a subsidiary guide, use a spacer to precisely maintain the gap after the assembly, after the measurement. Now let's talk about the designing of LM Guideways mounting arrangement, especially for ball screw based linear actuator. So in ball screw based linear actuator, we always need a space between the base plate and the sliding plate for the screw and nut. So we use a spacer block under the LM Guideways. And best practice is make these spacer oversized, weld them roughly, and leave for 2-3 days to release the welding stress, and then do the final machining of alignment steps in one go. Something like this. And then install the rails and block. So this was all about the master and subsidiary guide rails concepts and their different mounting arrangements. And now let's understand the manufacturing tolerance of LM Guideways mounting arrangement with a simple example. Let's say we are designing a ball screw based linear actuator and we have used Hyvin HG series LM Guideways, a nominal size 20, a heavy load ball type guideway. So there are two critical tolerances that we must control during the machining. First is parallelism between the alignment step of the both rails, and second is allowable height differences between the resting faces of both rails. And these both tolerances depends on the preload class of LM guideways we have selected. So first let's understand what is LM guideways preload class. So as I said earlier, the LM guideways have negative clearance between groove and balls. This is to improve the stiffness and maintain high precision during motion. So higher the negative clearance means higher the preload, and higher the preload means higher the rigidity and less deflection under load, as you can see in this graph. Now, the LM guideways are generally available in three preload classes: light, medium, and heavy. Hyvin defined these preload classes as ZO, ZA, and ZB, whereas THK defined them normal class, normal clearance, clearance C1, and clearance C2. But both are referring to the same thing. So the question is how to choose the right preload class. So if in your application, the loading direction is fixed, impact and vibration load are minimal, and you are using two LM rails in parallel, very high precision is not required, and system demands very low sliding resistance, then go with lighter preload, ZO class. Applications like general linear actuator, material transfer system, XY axis automation machines, or welding fixtures, light preload is perfectly fine. Now, if your application is subjected to overhang load or movement load are acting, or LM guides are used in single rail setup, even in parallel setup, but accuracy requirements are higher, like in industrial robot, high-speed feeders, or vertical access, or applications where precision matters, then go with medium preload, ZA class. Now, if your applications need very high rigidity and it's also subjected to vibration, impact loads, or changing direction of the load, like CNC machines, grinders, lathes, boring machine centers, where high stiffness and positional accuracy is critical, then go with heavy preload ZB classes. Just for note, the heavy preload class ZB is usually available only in non-interchangeable type guideways. Also, one important point to note, higher preload reduces the service life of the LM guideways, because under high preload, the rolling elements are already under compression without any external load. So the internal friction increases and eventually shorter the life of LM guideways. So don't choose a heavy preload class unless your application is demanding. Now, as I said earlier, at higher preload, the LM guideways become more rigid. But with more rigidity, it becomes more sensitive to the misalignment. So as we go for the higher preload class, we need to maintain higher precision in mounting, especially in parallelism between the LM guideways. Same thing you can see in this table. This is from Hyvin. Let's take the same size of LM guideways, SG20. For preload class ZO, parallelism tolerance P is 20 micron. For preload class ZA, it becomes 20 micron. And for the preload class ZB, it becomes more precise, just 18 micron. So if this linear actuator is being used in CNC machine, then we must go for ZB preload class, and we will maintain 18 micron parallelism between the mounting surface of the guide rails. But if it's a general purpose actuator used in non-CNC application, we can simply choose ZO preload, and 25 micron parallelism is acceptable. Now, the second critical tolerance is height difference between the resting faces of both guide rails. This height difference also depends on preload class of the LM guideways. So again, let's consider ZO preload. Then the maximum allowable height difference S1 is 130 micron, as shown here. And just to clarify, this is not the flatness of the surface. This is the allowable height difference between the two mounting faces of the rails. Like one may be 0.13 mm, 130 micron, higher or lower than other. As for flatness, Hyvin hasn't defined it for HG series. They have only defined it for MG series. So to refer a standard flatness value, We can check THK SRS series for size 20, which mentioned flatness tolerance at 0.07 mm for 200 mm length. Now, for the depth of the solder radius for alignment steps, we can consider this table here. You can find these similar tables in any LM guide manufacturer's catalog. This is just an example. So for HG20, the maximum flit radius R1 at the corner of guide rail alignment step is 0.5 mm. Same for the LM block alignment step. The corner radius R2 is also 0.5 mm. And then solder height beside the rail E1 is 3.5, which is the required height of the alignment step for the guide rail. And for the solder height beside the block E is 5 mm, which is the alignment step height for LM block. Now we have almost all the dimensions and tolerances. So now let's create the manufacturing GD&T drawing of this LM Guideways mounting arrangement, because there is one particular very interesting GD&T lesson. So this is the base mounting. First define all the sizes and locational dimensions depending on your actuator design. But here we will mainly focus on LM Guideways resting faces. So let's say this is master side resting faces and this is subsidiary side. So on master side, I have defined resting faces as a primary datum A and the alignment step surface as datum B. And the idea behind doing this is we will control the subsidiary side with respect to the master side. Many designers define the base as datum and then control the both resting faces with respect to the base datum. But that's not functionally correct, because functional requirement is control the resting face with respect to each other. The base face can be simply controlled by applying a parallelism control, let's say 0.1 mm with respect to datum A, the resting face, and let's make this front face as datum C. And now let's apply the critical tolerances. The parallelism between the both alignment phase is 25 micron, which is defined over a feature of size, not as parallelism of one phase to the datum. So in the same way, we will also apply it directly over the dimension between the both features, like so. Now the next one is the height differences between the both resting phase, 130 micron. This means both distinct phase should lie within a band of 130 micron. So how to define this? You might think use flatness, but flatness will only control surface individually, not the height difference between two distinct surfaces, right? You might say parallelism, but parallelism only means both surfaces must be parallel. It doesn't say how far apart they are. Height difference can be anything under parallelism control. So you might say, why not simply define it with height dimension and apply the tolerances? Like give both surface height with plus 130 micron. Actually, that's fine too. But in this situation, it's better to use profile tolerance. We can apply it over one surface with a 2 multiply annotation like this. This means these two distinct surfaces must be lie within a 130 micron tolerance zone, regardless of any datum. We will learn more about profile control in our GD&T series. Now the flatness of both resting surface. So as per recommendation, let's apply 0.07 mm per 200 mm length. Now the tolerance between the alignment steps. So we can apply a general tolerance plus minus 0.1 mm. Why? Because on subsidiary side, the LM block is mounted with clearance holes only. So the subsidiary guideway can shift its position within the mounting clearance. For example, if LM blocks use M5 bolts, The clearance hole in this plate would be 5.5, which give us 0.5 mm total tolerance. So even plus minus 0.25 mm could work. But here let's keep it plus minus 0.1 mm, which is totally fine. Now the position tolerance of the rail mounting holes, so we can define it within 0.2 mm or 0.1 mm with respect to datum A, B and C. And for the mounting heights, that depends on the application. Here I'm just defining it within plus minus 0.1 mm. Now for the sliding plate, first define all the size and locational dimension as per the design, and then let's define the datums. So the master block resting face becomes our datum A, and the alignment face becomes datum B, and the front face becomes datum C. Now these are the again distinct surfaces. So instead of applying flatness, we will apply profile control with the recommended tolerance of 0.07. You can find this drawing PDF in video description. Now after manufacturing of all these parts, we should follow some standard guidelines during the assembly, during the installation of LM Guideways. First, we should inspect the manufacturing parts as per the drawing, mainly the height differences between the resting face and parallelism between the alignment steps, because these are very critical. Second, we make sure there is no dirt or burr or scratches over the resting faces. For that, we can use oil stone or white stone to clean them properly. Next, place the guide rails and make sure the reference faces of each rails is properly in contact with alignment steps. For the rail, the reference surface is marked with an arrow. And for LM blocks, it's grinded side face, not this rough one. Now, here is a pro tip. When we design a double guide rail arrangement, the reference surface will be always face in opposite directions. So always maintain symmetric ends in guide rails. For example, if one end is 20 mm from the last mounting hole, make sure the other end is also 20 mm. So you can flip the guide rails if needed to match the reference surfaces for the both rails. And after placing the guide rails in correct orientation, tighten the mounting holes with partial torque first, not full torque yet. Then tighten the clamps, whether you are using a push plate or taper gibs. And then go back and fully tighten the mounting holes of the guide rails with recommended torque value from the manufacturer table. For example, if you are using M5 bolt size and mounting plate is mild steel, tighten the bolts with 883 Newton centimeter torque. And then finally put the bolt hole caps like these, included with LM Guideways, and flush the cap and make them even with the rail surface. And once the rail is installed, then install the LM blocks one by one. Use these rubber spacer while inserting the block into the rail, otherwise balls inside can fall out. And do the same when we're removing the blocks from the rails. And after installing the blocks, place the top sliding plate, align with the holes of LM blocks, tighten the side clamps, and then tighten the LM blocks in diagonal sequence. And check the movement. It must be smooth and accurate. And that's my promise. So this was all about the LM Guideways mounting arrangement and the installation process. I hope this video helps. If it did, please give us a like. Now, we have to also understand the running accuracy of a LM Guideway is not only depends on the installation method, it also depends on the geometric tolerance of the LM Guideways themselves. And we define it as LM Guideways accuracy class. So the video should be on your screen, and thank you so much for watching this video.